Hi Ravi,
गुड इवनिंग सर।
good.
गुड इवनिंग सर।
Good evening. Are you getting my voice or not?
हाँ, यस सर, यस सर, नाउ
How are you? All good?
गुड सर, गुड।
So have you able to do little practice or not?
हाँ, ना ना सर।
Hmm?
प्रैक्टिस, हाँ प्रैक्टिस हो रही है सर।
हो रही है.
हाँ।
How much? Do you
एक्चुअली
have
क्या
any
है
doubt?
अभी,
Anything?
एक्चुअली अभी स्टील गर्डर वाला पड़ा है उसमें। वो कॉपी कर लिया ना सर पिछले वाले से।
हाँ पहले तो आरसीसी कंप्लीट हुआ था. अब
हाँ
स्टिल.
हाँ सर। आरसीसी वाले में मैंने आधा लोड
हाँ
लगा के रन करा
आरसीसी था.
दिया था।
हाँ पीसीएससी था. देखो लोड तो वही रहेंगे लेकिन चीजें जो चेंज होती हैं वो यही होती हैं. जैसे
हम्म,
कंक्रीट से पीसीएससी पे आ जाते हैं, पीसीएससी से स्टील पे आ जाते हैं. ये होता है
वही
ज्यादा.
मैं कह रहा हूँ सर। पिछले वाले पीसीएससी में मैंने आधे लोड लगा दिए थे, आधे में रन करा दिया था। अभी
अच्छा
उसको
अच्छा.
पूरा करना पड़ेगा।
हाँ नहीं पहले वो पूरा करो, बिल्कुल कोई इशू नहीं है.
हम्म,
ऐसा कोई वो
नहीं
नहीं है
इसका
कि.
इसका भी जितना दो लास्ट दो सारे कंप्लीट है सर स्टील वाले पे। उसके लोड
अच्छा
केवल
स्टील.
रहेगा सर।
हाँ
हाँ
लोड में दिखा देता हूँ भैया. थोड़े लोड मैं बता भी देता हूँ थोड़ा डिफरेंट तरीके से. चलो मैं शेयर करता हूँ स्क्रीन. बाकी आ ही रहे हैं अभी. तो इसमें जो लोड लगेंगे, सबसे पहले तो अपना सेल वेट तो हमने उस दिन लगा के चेक करा था कि सही आ रहा है नहीं आ रहा. तो और लाइव लोड भी लगा लिए थे हमने. तो इसमें अब हम बाकी लोड लगाएंगे. जैसे क्रैच बैरियर होता है और अपना वेयरिंग कोट होता है. तो क्रैच बैरियर के लिए मैं एक डमी बीम बना दे रहा हूँ. वो भी कर सकते हो ज्यादातर. अगर पुराना मेथड यही होता था, लोग डमी बीम बना देते हैं एच पे और उस पर डायरेक्ट लोड लगाना वो भी आसान होता है. तो यहाँ पे ऐसे मैंने क्रिएट करा हुआ है, जैसे पहले से ही डमी बीम 1 बाय 1 की. यहाँ क्लिक करके यहाँ तक. और
सर।
हाँ हाँ बोलो.
अगर अगर हम डमी ना करके पूरा उसका स्लैब का वेट दे दें फिर उसमें कोई प्रॉब्लम होगी?
स्लैब का वेट लिया हुआ है ना हमने हमने डायरेक्ट गर्डर प्रॉपर्टी में ले लिया ना स्लैब का वेट. अगर तुम देखोगे, जो स्लैब का
जैसे
वेट हमने लिया हुआ है.
जैसे हम डमी स्लैब करके उसकी डेंसिटी जीरो कर देते हैं,
हाँ
उसको
हाँ.
एज इट इज रहने दें। उस पे नहीं चेक कर सकते क्रॉस?
एक मिनट, एक मिनट, एक मिनट तो मैं जरा. हेलो.
सर,
हाँ रवि. हाँ आप बताओ क्या कह रहे हो.
कल जैसे हम डमी स्लैब बनाते हैं ना,
हाँ
डमी स्लैब बना के उसका मटेरियल सेलेक्ट करके उसमें
हाँ
जो भी
डमी कर
उसका,
देते हैं प्रॉपर्टी को.
हाँ,
बिल्कुल सही.
डमी कर देते हैं, उसको जीरो कर देते हैं।
हाँ
जीरो ना करके एज इट इज जैसा है वैसा रह देंगे
तो
देंगे
डबल हो जाएगा ना.
तो
स्लैब पहले ही हमने अपने कंपोजिट गर्डर में कंसीडर कर ली ना. जो
अच्छा।
यहाँ पे डिफाइन करा है ये मिड गर्डर, इसकी प्रॉपर्टीज देखोगे तो यहाँ पे हमने पहले ही स्लैब को कंसीडर कर लिया ना. ये टॉप स्लैब ये यहाँ पे कंसीडर है. अगर तुम उसको डमी नहीं कंसीडर करोगे तो 2 बार स्लैब का लोड लग जाएगा.
ओके ओके।
हाँ समझ रहे हो. तो इसलिए वो भी कर सकते हो, लेकिन फिर क्या होगा, फिर डिजाइन चेक नहीं कर सकते. वो हम करते थे इसमें स्टैट स्टैट में. जो पुराने सॉफ्टवेयर होते हैं ना, तो पुराने जो लोग काम करते थे वो पहले करते थे कि आई गर्डर नॉर्मल मॉडल करते थे, स्लैब को एज ए कंक्रीट मेंबर मॉडल करते थे. लेकिन उसमें हम कुछ भी सॉफ्टवेयर में डिजाइन नहीं करते थे, बस रिजल्ट निकालते थे. फिर हम एक्सेल से डिजाइन करते थे या मैनुअली करते थे. वो ओल्ड मेथड था. वो भी होता था.
ओके ओके।
हाँ दैट वाज देयर प्रीवियसली, बट राइट नाउ इट वाज नॉट.
नहीं, अभी तो जनरली जैसा हम कर रहे हैं सर, आई बीम, आई गर्डर लेते हैं उसको,
हाँ
इंस्टा इरेक्ट
इसको बोलते
करके
हैं
उसके
कंपोजिट.
ऊपर।
कंपोजिट सेक्शन है ये, कंपोजिट.
हाँ ओके। दैट इज
कंपोजिट.
T1
हाँ स्टील बीम है और कंक्रीट की स्लैब है तो कंपोजिट बोलेंगे. या अगर मेरे पास पीसीएससी भी होता और मेरे ग्रेड ऑफ कंक्रीट अलग होते उसको भी कंपोजिट बोलते हैं.
नहीं,
कंपोजिट
इसको
मतलब दो.
नॉर्मली वो प्रीस्ट्रेस गर्डर की मैं बात कर रहा था।
हाँ प्री स्ट्रेस में भी कंपोजिट बोलते हैं अगर मेरी स्लैब और बीम का ग्रेड अलग होता है. सेम होता है
हम्म,
तो मोनोलिथिक उसको भी कंपोजिट ही बोल लेते हैं, लेकिन उसमें ग्रेड सेम हो जाता है. कंपोजिट कब बोलते हैं? जब आपका बीम अलग कास्ट हो रही है और स्लैब अलग कास्ट हो रही है, लेकिन अब हमें उन्हें एक तो करना ही है,
हाँ।
तो उसको कंपोजिट बोलते हैं। लेकिन कंक्रीट कंक्रीट एक साथ मिल जाते हैं, तो अगर एक ही सेम प्रॉपर्टीज होती है तो मोनोलिथिक कह लेते हैं, लेकिन डिफरेंट होती है तो कंपोजिट। और अगर यहाँ पे स्टील और कंक्रीट है तो कंपोजिट। कंपोजिट मतलब दो अलग मटेरियल से मिला के बना रहे हैं।
इसमें भी सर जैसे स्टील गर्डर में भी हम करेंगे तो पहले स्टील गर्डर ला के रख देंगे, उसके ऊपर ही स्लैब करेंगे।
हाँ हाँ, उसके ऊपर स्लैब कास्ट करेंगे, वो लगती है शटरिंग।
हाँ शटरिंग
शट
ओके।
टेम, हाँ टेम्पररी शटरिंग या परमानेंट, बहुत से परमानेंट भी लगाते हैं, डिपेंड करता है जिसको जैसा मानो। तो परमानेंट लगा रहे हो वो भी अच्छा है, उससे स्लैब को और ज्यादा स्ट्रेंथ मिल जाती है।
तो
और वरना
इसमें जैसे
टेम्पररी।
अभी एक थोड़ा सा कंफ्यूजन है सर, जैसे इसमें अभी
बताओ।
स्टील गर्डर, अभी आप मिड गर्डर दिखा रहे थे ना, तो
हाँ हाँ, ये
मिड
रहा।
गर्डर में उसमें स्लैब का कुछ पोर्शन ले लिया है।
ये है ना स्लैब, कुछ नहीं, जितनी
हाँ
हमारी विड्थ है उतनी लिया है, 2.5 लिया हुआ है।
ओके ओके। लेकिन
हम्म।
इसके बाद भी गर्डर इरेक्ट करने के बाद भी हम तो स्लैब रखेंगे ना।
वो अभी हम अलग करेंगे जब हम कंस्ट्रक्शन स्टेजेस डिफाइन करेंगे। अभी हमने एक ही प्रॉपर्टी डिफाइन करी है, लेकिन जब हम कंस्ट्रक्शन स्टेज में जाते हैं तब हम अलग कर लेंगे स्लैब और कंक्रीट को ना। वो
ओके
इसको आई गर्डर और स्लैब को, वो मैं दिखाऊंगा अभी, अभी अलग अलग करेंगे।
ओके ओके।
हाँ हाँ, नहीं बिल्कुल, कोई कोई क्वेश्चन है, लोग इसमें ही कंफ्यूज होते हैं क्योंकि स्लैब बाद में कास्ट होनी है। लेकिन होना
हाँ
क्या है एक्चुअल में, फाइनल जब मेरा लाइव लोड के लिए मैं चेक करूंगा लॉन्ग टर्म के लिए, उसमें तो वो कंपोजिट बिहेव करेगा ना, आई गटर पे स्लैब आ जाएगा ना।
हाँ करेक्ट।
समझ रहे हो? तो हमें जो फाइनल चेक करना होता है वो कंपोजिट के लिए करना होता है, लेकिन कंस्ट्रक्शन स्टेजेस के चेक होते हैं। जब तक कंक्रीट नहीं आया तो उसके लिए स्टील गटर को चेक करना है। जब वो कंक्रीट का, ग्रीन कंक्रीट का वेट है, मतलब जब उसके ऊपर सिर्फ कंक्रीट डाला है लेकिन वो हार्ड नहीं हुआ, तो तब भी हमें अपना गटर चेक करना है, उसको बोलते हैं वो कंस्ट्रक्शन स्टेजेस के चेक। तो वो होता है, सब करते हैं, अभी हम सब करेंगे, लेकिन एक बार लोड अप्लाई कर लूं फिर हम करते हैं इसको।
उसमें सर फिर शटरिंग का भी डिजाइन आ जाता है ना।
शटरिंग का डिजाइन तो इसमें नहीं लेते हैं, लेकिन अगर तुम्हें करना हो शटरिंग तो बहुत आसानी से हो जाती है। डिजाइन की क्या करने की जरूरत है, डायरेक्ट सुपर स्ट्रक्चर के लिए तो डायरेक्ट ही लगा देते हैं। सपोर्ट कंडीशन देखनी होती है, स्टील कटर के लिए बहुत आसान होती है शटरिंग लगाना, मैं बताता हूँ क्यों।
नहीं जैसे हम लोग का जैसे ग्रीन कंक्रीट डालेंगे, वो शटरिंग हमारा उतना लोड रेजिस्ट कर पाएगी कि नहीं, वो उसके लिए भी
वो
डिजाइन।
पहली बात तो शटरिंग जो होती है हमारी होती है वुड की, ठीक है। बट वुड
वुड
की
का।
तो होती है, ज्यादातर जो शटरिंग होती है वुड या
नहीं सर
एल्यूमिनियम
इसमें
की।
हाँ एल्यूमिनियम वुड वाली
हाँ
एनएच में अलाउड नहीं रहती है।
हाँ,
वो एल्यूमिनियम वाली जीआईसी
मतलब
में।
मेनली यही रहती है, लेकिन अब तो पहली बात, इंडियन कोड कुछ भी बताता नहीं है वुड के डिजाइन में ज्यादातर। दूसरी चीज ये है, जो एल्यूमिनियम का या स्टील की होती है, जैसे कॉलम की शटरिंग हो गई, ठीक है, उसको डिजाइन करते हैं टेम्परेचर लोड के लिए और सेल्फ वेट कंक्रीट के लिए बस। क्योंकि इसमें जैसे हम कंक्रीट डालते हैं, कंक्रीट का टेम्परेचर बहुत हाई होता
हाँ यस।
है और उसके साथ वाटर भी होता
अराउंड 35 36।
है। हाँ नहीं, और ज्यादा ही मान के चलते हैं मतलब। तो वो बेसिकली जो शटरिंग का डिजाइन होता है वो होता है, एक तो आपका डेड लोड आ रहा है, ऊपर से हम वाटर का लोड भी थोड़ा मान के चलते हैं, क्योंकि पानी भी होता है कंक्रीट में, गीला होता है कंक्रीट,
यस।
ठीक है। तो ये दो लोड प्लस टेम्परेचर, इन तीन लोड की वजह से हम शटरिंग चेक करते हैं अपनी बस, और कुछ नहीं करते। लेकिन इसमें शटरिंग लगाना आसान क्यों होता है, इसमें होते हैं ये फ्लैंज, बॉटम फ्लैंजेस। तो क्या करते हैं, इसके ऊपर ही टिका के अपनी शटरिंग लगा लेते हैं।
और वो जो सर उसमें पीसीएससी में भी नीचे बॉटम फ्लैंज दिया
हाँ
रहता है
हाँ,
उसमें।
बॉटम फ्लैंज से ही उठा लेते हैं वो शटरिंग। शटरिंग के लिए बड़ा सही कॉन्सेप्ट होता है, लेकिन पीसीएससी में तो आजकल प्री वैसी यहाँ पे भी गैप छोड़ के रख देते हैं, इस जगह पे गैप छोड़ देते हैं करीब यहाँ
हाँ
पे, ताकि
उसमें
वो
छोड़ रहे
पैनल
हैं।
आके रखते हैं और वो कंक्रीट कास्ट कर
वो
देते हैं।
हाँ सेक्रीफाइस शटरिंग लगा
हाँ
देते हैं
हाँ
एल्यूमिनियम।
हाँ हाँ हाँ, सेग्रीगेशन शटरिंग बिल्कुल सही, वो परमानेंट रहती है।
वो निकालने की जरूरत नहीं है उसको।
हाँ हाँ, उससे निकालते नहीं है, उससे स्ट्रेंथ भी मिल जाती है हमें अपने कंक्रीट को, क्रैक व्रैक नहीं आते हैं, सही रहता है वो। मतलब एक
उसी
एडिशनल स्ट्रेंथ प्रोवाइड
हाँ
कराती है। हाँ,
उसी के
उसका
लिए मैं
डिजाइन
सोच
होता
लो।
होगा, उसका डिजाइन होता
हाँ
है, बस
उसका
सेल्फ वेट
उसी
के
का
लिए कर
डिजाइन
देते हैं।
में जैसे कभी कभी क्या होता है सर कि जैसे हम लोग का हाउसिंग कभी गर्डर में ज्यादा आ गई, किसी की में कम आ गई, तो उससे
क्या
स्लैब का
चीज?
थिकनेस वेरी। जैसे गर्डर की हम लोग की हाउसिंग ज्यादा आ गई, किसी गर्डर की कम आ गई,
हाँ 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 हाँ, होता है, ये
तो
होता है।
उससे क्या होता है हम लोग का स्लैब का थिकनेस वेरी करता है।
हाँ, स्लैब वेरी करा
तो
सकते हो, कोई इशू नहीं है।
स्लैब की
लेकिन
थिकनेस वेरी
हाँ,
करेगी, तो
लेकिन
कहीं
मिनिमम
जहाँ
फॉलो करनी
ज्यादा।
होती है। जैसे अगर 250 दी हुई है, 250 फॉलो करो, फिर उससे ज्यादा ले जाओ, जैसे 300 चाहिए हो, या उससे 25-30 mm करा सकते हैं, वेरी का कोई इशू नहीं होता।
हाँ, तो वहीं सर जहाँ पे अगर हम लोग की थिकनेस ज्यादा आती है, अगर 200 सपोज दैट
हाँ,
200
ओके,
एम
तो
का
वहां
जो
पे
स्लैब है।
300 आ गई है, 250 आ गई, तो वहां
हाँ,
पे शटरिंग
तो
चेक करनी है।
वहाँ शटरिंग कभी कभी क्या है सर, ओपन होने लगती है उसका वो।
हाँ बिल्कुल, क्योंकि वो डिजाइन हुई भी है अपने 200 के लिए, और तुमने डाल दिया कंक्रीट ज्यादा।
हाँ यस।
हाँ, वो आती है, वो होती है।
उसके
ये
लिए
तो,
सर।
लेकिन शटरिंग का कुछ ज्यादा मायने मेजर कुछ नहीं होता। एक तो होती है स्टेजिंग, और एक होती है शटरिंग। स्टेजिंग तो समझ गए ना, स्टेजिंग लगती है शटरिंग से पहले।
हाँ।
स्टेजिंग का तो डिजाइन होता है प्रॉपर, क्योंकि स्टेजिंग ज्यादातर बनती है स्टील की। स्टील के वो बनते हैं क्लैंप, और ये अपनी रॉड्स, यू क्लैंप्स होते हैं, रॉड होती है, उस पे चैनल्स होते हैं, फिर उसके ऊपर शटरिंग आती
उसके हाँ, वो
है
तो
ना।
ठीक है सर।
हाँ हाँ, तो स्टेजिंग जो होती है उसका डिजाइन तो मैंने किया, लेकिन शटरिंग का जरूरत इसलिए नहीं पड़ती। ज्यादा कॉन्ट्रेक्टर यही बोलते हैं कि भाई जो भी, क्योंकि शटरिंग का एक वो होता है हमेशा प्रोवाइडर, पता होगा तुम्हें, थर्ड पार्टी से आती है शटरिंग हमेशा।
हाँ यस सर।
तो वो हमेशा जो थर्ड पार्टी से शटरिंग आती है वो खुद ही डिजाइन करके देता है, और उसी में लिखा होता है कि इतने के लिए वैलिड है और इतने के लिए नहीं है वैलिड।
हाँ, थर्ड पार्टी पे छोड़ देंगे इसमें।
हाँ, वो ज्यादातर थर्ड पार्टी से आती है, वो कभी भी हमारा इंटरनल डिजाइन नहीं होता, या फिर डिजाइन वाले इन्वॉल्व भी नहीं होते उसमें। क्योंकि जो बना रहा होता है ना शटरिंग, जैसे तुम्हारा बियरिंग का हो गया, बियरिंग भी हम डिजाइन नहीं कर रहे, मैन्युफैक्चरर से करवा रहे, शटरिंग भी हम नहीं कर रहे, मैन्युफैक्चरर से करवा रहे। तो मैन्युफैक्चरर अपनी एक डिजाइन स्पेसिफिकेशन देता है कि भाई ये शटरिंग इतने स्लैब तक के लिए वैलिड है, अगर इससे ज्यादा जाएगी तो टूट जाएगी, या ये इतने लोड के लिए वैलिड है, वो कुछ ना कुछ देगा। या शटरिंग की ड्राइंग में भी लिखा होगा कि इतनी ड्राइंग होगी, अगर हुई उसकी ड्राइंग। कभी कभार कुछ भी नहीं होता, डायरेक्ट शटरिंग आती है और लग जाती है, क्योंकि वो किसी और साइड से निकल कर आ रही होती है।
हम्म।
तो उस टाइम पे कुछ भी नहीं होता, तो फिर यही होता है, जब से भाई जो भी है ये कहीं और यूज हुई है, उसमें फिर वो भी हो जाती है, पुरानी हो जाती है ना, तो उसमें क्रैक्स भी आ जाते हैं, क्योंकि जब एक जगह लग के जुड़ के
जनरली
फिर दोबारा।
जनरली
तो
जनरली तो सब नहीं आता, लेकिन रेयर केस में कभी कभी ऐसा है, जैसे हम लोग की इसी साइड पे ऐसा आया था, जैसे हॉगिंग किसी में ज्यादा आ गई थी, किसी में कम, तो स्लैब की थिकनेस ज्यादा हो गई थी, तो एक दो जगह ऐसा हुआ कि नीचे की जो शटरिंग थी वो थोड़ी थोड़ी खुल गई थी, मतलब लीक होने लगा था, स्लरी लीक हो
हाँ, तो
जाएगा।
ये तो साइड पे होता ही है ज्यादातर, फिर क्या करते हो, बांधो उसे, और क्या है, एडजस्ट करो। लेकिन
हाँ
मैं, यही होता है कि शटरिंग का जो डिजाइन होता है वो उस पर लिख, वो तुम्हें एक बार देखना पड़ेगा, उस पर एक लिमिट लिखी होती है कि ये शटरिंग पहली बात कितनी बार खुल के कितनी बार यूज हो सकती है, और कितनी स्लैब के लिए और कितने लोड के लिए डिजाइन है। अगर हमारा उससे कुछ भी ज्यादा होती है तो वो फेल कर जाती है ज्यादातर। तो एक ये भी होता है कि कितनी बार खुल के कितनी बार लग सकती है, क्योंकि शटरिंग बार बार खुलती है, बार बार लगती है, उसका एक लाइफ स्पैन
हाँ,
होता है।
और वो कोड में दिया हुआ था,
कोड में
6 से 7 टाइम
नहीं, वो
से ज्यादा।
ये अपने जो मैन्युफैक्चर होते हैं वो एक्सपेरिमेंट करके रखते हैं, वो बता देते हैं, वो कोड अलग है, लेकिन उनका जो एक्सपेरिमेंट होता है वो बता देते हैं क्लियरली, ये 10 बार होगी या 20 बार होगी या 30 बार होगी, अलग अलग। फिर वो शटरिंग की स्पेसिफिकेशन पे भी डिपेंड करता है, कौन सा मटेरियल यूज कर रहे हैं और क्या कर रहे हैं।
हाँ, और साइड पे कैसा शटरिंग और कैसा यूज
हाँ,
हो रहा
साइट पे
है।
भी कि सही से लेके जा रहे हैं, नहीं जा रहे हैं, लिफ्टिंग ठीक है और मूविंग ठीक है नहीं है, कभी कभी कभार लिफ्टिंग और मूविंग में भी वो हो जाती है, वो खराब। तो शटरिंग का तुम्हें टेंशन लेने की जरूरत नहीं है, अगर कभी फेल भी हो रही हो तो सिंपल ये देखो कि भाई उसकी वो कहाँ है, ड्राइंग या मैन्युफैक्चर, और नहीं है तो फिर छोड़ दो, वो बस एडजस्ट कर लेते हैं साइड पे ऐसे। शटरिंग का इतना मेरा इशू कोई डिजाइन से रिलेटेड आया है कभी? स्टेजिंग का तो आता है, हाँ, स्टेजिंग अगर फेल कर गई तो तुम्हारा पूरी शटरिंग गिरी जाएगी। स्टेजिंग का डिजाइन होता है, स्टेजिंग का तो किया भी है, क्योंकि स्टेजिंग में तो आपके बंदे खड़े होते हैं ना, वो कंक्रीटिंग कर रहे होते हैं, पोरिंग कर रहे होते हैं। अगर स्टेजिंग फेल कर गई तो पूरी वही कंक्रीट गिर जाएगा, अपना हार्ड ही नहीं हो पाएगा।
गया वो तो।
स्टेजिंग का अगर डिजाइन होगा तो वो स्टील के थ्रू ही होगा, वो थोड़ा बहुत बता दूं कि जैसे हम ब्रेसिंग डिजाइन करते हैं वैसे ही स्टेजिंग डिजाइन होगी।
ओके।
तो हाँ, वी आर एट हेयर, ओके। अब हमें ना लोड जो लगाने हैं, तो जैसे इसको थोड़ा हम देख लें कितना एक्सटेंड करना था। कितना हो रहा है नेक्स्ट टाइम, ये इतना है तो इतना ही ले लेंगे हम। फिर हम जाएंगे अपने नोड एलिमेंट में एक्सक्लूड में, और यहाँ पे डमी अनइक्वल डिस्टेंस एक्स माइनस, तो नाउ हम अपना लोड लगा सकेंगे। सिंपल है वो, तो हमने लोड्स में जाके एलिमेंट लोड यहाँ पे सिलेक्ट कर लेंगे। पहले हमें कौन सा लगाना है, क्रैश बैरियर, और डिफॉल्ट अभी ग्रुप नहीं बनाए हैं तो एक बार ग्रुप भी बना लेते हैं। सल्फेट एसएफ सीबी क्रैश बैरियर डब्ल्यूसी वेरी गुड, और एक और आएगा ग्रीन कंक्रीट। So these loads will come in the group. Now we can do again that here CV C crash barrier load. Select this, and we know previously how many times, so it will be minus 12.5. Apply, it will look like this. Now another load will be your bearing code. So how bearing code will be calculated? Like for mid girder, it will be 2.5. So 2.5 multiplied by depth, 2.5 multiplied by depth, 0.65 generally the most common one, into density is 22. So 3.575 for mid girder. So we will change this into WC. Oh, I put it in the bearing code. Control this barrier. Like now change it into bearing code. WC. So for mid it is coming around 3.575. And for this one, from one end it is 1.25 and another end is 1.3, and from 1.3, 0.5 is already taken by our crash barrier. So 1.3 minus 0.5 remaining 0.8 plus 1.25, 2.05 into then same thickness into 22, 2.9, so it is coming around 3. So this will be my bearing code. This will be now there will be wet concrete. So for wet concrete, we are going to apply wet concrete transversely, and we remember it how much spacing I think I have used it. We can go and check it, or we can easily able to measure that from this to this point. 1.5, 1.5 for this mid, and for these 2.5. Okay, so we will go green concrete mean it will come ये जब आएगा जब हम अपने ये कंस्ट्रक्शन स्टेजेस के टाइम पे अपना गर्डर चेक करेंगे। मतलब स्टील गर्डर होगा, उस पर स्लैब का लोड, मतलब स्लैब कास्ट हो रही होगी लेकिन वो कंपोजिट नहीं बना होगा, उसके लिए हमें ग्रीन कंक्रीट की जरूरत होती है। ग्रीन मतलब ताजी ताजी, मतलब एकदम ही आया और डाल दिया उसके ऊपर, तो उसके लिए हमें चेक करना पड़ता है। So now I will go into the again load element. This will be my wet concrete, green concrete. So this will be how we will calculate it. Again, our depth is 0.25 multiply by 1.5 multiply by density. And this will be 9.35 for, I can select my element by go here, slab 1. You can select by this, then element 9.375 wet concrete, green concrete minus 9.375 apply. And now another one will be I can open. Now we will again open the whole model and come here, select slab 2. For this one, it will be little higher.
So slab 1 which one, sir? Slab 2 which one, sir?
Slab 1 is for 1.5 meter width and slab 2 for 2.5 meter width. No, I have differentiate.
No,
because of distance.
Spacing, no, sir.
No, slab is also na in the mid. If you see, slab have more spacing. So I have not changed the spacing, so I just adjusted. Because of this bracing, I have not changed. I have not keep it equal distance, but according to the bracing, I have just adjusted.
Okay, okay. You have moved the slab, this line,
yes.
transfer elements, sir.
Yes, yes. Just for green concrete. This load will going to remove. This will be going to check in construction stage only.
Normally means as per our drawing means it is everywhere 2.5, no, sir.
Yes. No, as per drawing, it depends. This is as per the modeling. You can change transfer beam as per your requirement. It is not fixed. As per modeling, I have kept, as per drawing, I have kept only this, our bracings equally. But this thing you can change if you want. Just I'm keeping the same thing. It's not mean you have to follow it. You can change to 1.5. You can change into 2 meter. You can change into 1 meter. It's up to you. So I have different. That's why I am showing. If you got different slab, then okay, you can define a different width and define the different load. No issues with it. So it totally, like if you are changing any width, so load will going to change.
This is based on our bracing spacing. This will vary, no, sir.
Yes. As per the bracing spacing, because that was not equal spaced. That's why. In the mid, we have more spacing. At the end, we have less spacing. So this will be minus 15.625, and this will be wearing to apply. Okay, now if you look into and go into our model. So we have applied self-weight, we have applied the crash barrier, we have applied very force, press testing do not required. Right now I am not considering wind one, but I will consider temperature. Uniform temperature I will again consider this for beam only. So I will select this, and we'll go into the temperature one, and we will click element temperature. Here you can define it. Do not require any group. Positive temperature 25. Select all. Because it will generate your longitudinal shear. That's why it is important if we are going to check our shear strength. So now these both have been applied, and also we require the temperature gradient. So for that, I need to fill the code again. IRC6. Same method, but temperature is very important in steel girder. If you do not consider it, it might fail, because we need to check the stresses to the and combine it. Temperature gives you stresses. So again, beam section temperature.
So yesterday bearing you have applied, sir. What you have done, sir, yesterday?
Yesterday, I think no, we have applied the live load and special vehicle. These all things.
Live load and special vehicle, sir.
We have created a special vehicle live load, and we connected this bearing and everything. So we check the model length for self-fit and the live load. So only these loads are remaining. Then we will just start the yes, it's fine. So now here, what will happen?
All load is similar to our this one, sir.
Yes.
Same like our RCC girder, PSA girder, same type, no, sir.
The loading or design?
Live load.
Live load is same, but special vehicle need to be created in your permit truck. I think I have shown you. If remember, I do not know. Maybe you know or not. But if you go into the moving load vehicle, a special vehicle will not come and standard. We need to create our user-defined vehicle in permit truck. So in this, I will also create one more truck, fatigue truck. So that's also we will able to run. Now here enter temperature, again the same we will use like for PCSC composite. This is our composite one. So again from top our width is around 2.5 meter, and our H1 0 to 0.15. It is going 17 to 0.44, 17 to 4. Add. Then again for this one also 0.15 to 0.3. Now here it is that we can consider 2.5, or because what is going to happening here, it will come within the haunch also, because our width is right now 2.5. Slab width is depth is 2.5. So and 1.15 we already used, so 0.1 is remaining, and after that we required only 0.5 that is coming in our haunch. So for that we can little able to reduce that, like for 2 meters, not less than 2. So this will come here, and this 4 degree goes into 0 degree. And
so total depth is 2.2 meter now, sir.
No. And the here is required width. Total depth is different. Total depth is your girder depth, but we need to see this H now.
That is 0.25, na, sir. Slab
0.25. So we have used 0.5 in the first one, in this range. Okay. After that, remaining one is 0.25 again H2 as per this. 0.15. Okay. H2 is also should be less than 0.25. Yes, it will be inside of. Yes. This is. So that is also required again 2.5, and that will be yes, same, just modified it. So after that we need to consider from the bottom. Now from bottom, how it is look like? From bottom we will need to consider the steel one. If you look at here, now here the width is 850, but the height is around 45. Now we need to calculate our area. First of all, this area plus the remaining one of this. If you This is this is fine. Okay. In the top we required it, for steel we do not require at the bottom. This is for the concrete bridge deck, and this is the steel deck. We do not require from the bottom. So H1 is 0.2. Wait a moment. 0.6 H should not be 1. 0.2.
So you have applied for concrete types, sir.
No, concrete are different. I need to update. I just forgot about it. We need to apply it according to this thing. H1 generally this is the limit, but if it less than sign is not showing, that is what I'm looking. H1, H2. That is how our bridge will look like. So H1 is H is mentioned and we have around 18 degrees, then 4, then 0, we have again 22 degrees. Consider the maximum 118, but I'm a little bit why they have mentioned. Generally for steel, yes, we need to change it for intermediate slab thickness. Even may be interpolated. Okay. So we have 0.23. Okay, if we depth of slab is 0.2, so the temperature should be 18, and if the depth is 0.3, then we have 0.25. So temperature will be between these two, 18 plus 20.5 divided by 2, 19.25. 19.25, and this will be for H1. H1 is 0.6 H, and the main thing is what is this mentioning from here? Because H is this one. H is your total depth of our slab, like, so H1 will be 0.6 into 0.25. So it will be 0.15, again same as come 0.15, but has to have been mentioned M. M generally do not. There it should be H. Something is mentioned, nothing have been mentioned. Not mentioned, so we will assume it is 0.4 H. So it will be 0.4 into again 0.25. It is giving 0.1, same, it is coming 0.25, but the temperature will be 19.25, 4 and 0. So here just need to change this. In this will remain same, but this 17 will be changed into 19.25. And you can click modified. This will remain same, 0.152. It will go 0.25. Again,
This
width will be
2.5
same.
is what, sir? 2.5 is what, sir?
Let me show you this diagram. If you're looking at this diagram, this is 0. Now up to this position is 0.15. By calculating, multiply 0.6 into H. H is how much? 0.25. So you will get 0.15. Now for this one, this is your H2. For H2, how much it is mentioning? 0.46 H. because M I'm not able to see where it there. So if you, or maybe here where it is, nothing have been mentioned. M is meter, man. Sorry. M is just meter, so that is why. So this, okay, this is mentioning 0.4. Yes. Okay, this will again going to change. So here, what is going to, we need to calculate from this to this point. So 0.5 we again taken. So here I will consider 0.4. Previously, what I am assuming is 0.4, maybe wrong represented as 0.4h. So what will be the 0.4h? If you multiply 0.4 into 0.25, you will get 0.1. And if you add 0.1 plus 0.15, you will get 0.25. So it should be 0.4.
No, not about this height, sir. With about 2.5 is there, no, that one.
Width, man, width. Because the space, center to center spacing of girder is 2.5.
Okay.
Because that is totally width, nothing else. Now we will have both the, and we will select temperature gradient plus. Select this. So now if you're able to see that how it will look like. Has been applied. Now again for -1, it is mentioning for 0.2, 4.4.
Sir, 19.25 to 4 degree, then again 4 degree to 0, no, sir?
0. Yes, here it is mentioned.
4 degree where it is mentioned, sir?
Here it is mentioned.
Okay.
Now, if you look at the negative fall have been mentioned. Positive is only on the pattern, but fall is different. If you look at here for the fall, we have only top, which is H1, which will be 0.6 H, and which will be -4 degrees. From the bottom, it is showing 8 degrees to 0 degrees. So fall will be higher for steel girder and concrete, and for increasing temperature, it will be higher for concrete, because concrete will try to expand, not steel, because steel is pretty much very resistant to the hot temperature. But for your this lower temperature, this will go like this. Now for this, how we are going to define it? This will be totally different one. So delete this or just change into negative. Delete top. Again, this will remain 2.5. Again, this. So this will be -4 degrees to 0 degree. And we will keep add. Now the main important part from the bottom. So from bottom, this will not be 2.5. Why? Because bottom has the steel that I was trying to explain the previous. Now, if you look at here, how much we need to provide from the bottom? Code is saying H2 is 0.4. So it should go 0.4. And what is available to us? 0.45 is taken by 850. So first of all, we need to calculate our area. How we are going to calculate this steel area? First calculate this 850 into 450, 45. So we will have some area, and we need to calculate 400 minus 45. We'll get 355 into this web 25. 355 into 25 plus the area we have calculated from 45 into 380, which was 38250. So we'll get the total area and divide this by 0.4. By dividing. Okay, no. 400. So I'm getting 117 or 120 width. This will be 0.12. This is going 0 to 0.4. Temperature changes from -8 to 0. Just add tag bottom. Okay, select again beams. One moment. Why did I? And now apply.
Sir, bottom one is area divided by height, sir.
Area divided by height. So we will get the width. Ravi, what are you saying?
सर ये जो हम लोग टेम्परेचर लिखते हैं ये मिडास में फ़ारेनहाइट में तो नहीं दिया हुआ है, एफएस लिखा हुआ है।
कहाँ पे?
तो हम लोग
ओके
इसमें
ये ओके एक मिनट मैं इसको अपडेट कर दूंगा, कोई इशू नहीं है। मेंशन तो फ़ारेनहाइट में है, ये डिग्री में होना चाहिए, फ़ारेनहाइट में जो आ रहा है। एक मिनट अभी कर लेते हैं चेंज। It is showing Celsius 812. And now what we will do?
ये सेल्सियस दिया हुआ है सर, टेम्परेचर फ़ारेनहाइट बगल में सेल्सियस दिया हुआ है।
I got it. Your point. It is valid point. So if you go here, tables. So if you look at here, it have been applied in Celsius, so no issues in this. Close this. And now for this also we will check. This is also in Celsius, so no issue. Now this was in the Fahrenheit have been shown, so we will update here also. My table has not. Yes, here first value is. Now if you look at here, it is showing in Celsius also. So whatever we have applied, it's fine. You can change unit here. Here it is not. Here we can change kilonewton meter, or if you want to change, again come here and we can able to change. Here temperature and all units are here. Or you can keep also set default. Press OK. So all temperature are showing in Celsius. See. And if I look at this one, close this. This one I have written 19. Okay, both are here. So what we can do, we can sort out our according to load case. Now if you look at here, -4 in Celsius, 19.25, and then first value is this, then -4 to 0, 19.25 so 4, and there will be another. And we can also see it will look like, if you open the display, it will look like this. Yellow, everyone can see, na? And this one look like this. So both have been applied. Temperature, the main load I am applying right now, because temperature is critical for this one. Wind will not give you anything. Seismic also not applying right now, and braking will be required. So I am considering 2 lane. So one 170R or 2 class A. So 170R will be give me around 20 kilonewton that I will apply at 1.2 eccentricity, and that 20 kilonewton needs to be divided into 4 girders because I have 4 girders. So 20 divided by 4, 5 kilonewton. You can go again, load, static load, the element, select your braking, does not require. This will be, first of all, eccentricity, offset Z, I end 1.2, and load will be global X, 5. Select this, and it will be a position like this. And this I will just unhide. Okay, so I will only checking for this one because these are the main governing. I think I already teach you wind one and the seismic one how to calculate and apply it. Right now I am not applying those, but if anyone want to apply it, I can also. Let me create one more vehicle that is known as your fatigue vehicle.
Sir,
Yes.
this absolute and relative difference you told me, sir. What is the difference, sir?
Absolute and relative difference. So if you go into the element load, there will be relative value, there will be absolute value, and these are absolute value and relative are this x1, x2, x3, x4. So what is mean by that? If I have this longitudinal beam, okay, this have 2 meter, okay, and I have mentioned absolute 0 to 1. What is mean by this? It will automatically consider whole length from 0 to 1 is your length. But if I mention in absolute 0.5, so it will consider half of this length up to this position. It will apply load only at this position. But if this is not, this is relative one, and now if I want to apply the absolute one, okay, so absolute, what is going to be happen if I consider absolute 0.5? So 0.5 absolute will be there, like up to this. Absolute means absolute value of your beam. Relative means in terms of ratio from 1 to, like in percentage, from 0 to 1. Relative means percentage. Just remember, relative means percentage. And divided 0 to 1 ratio. Absolute will be according to your beam length. If you provide absolute 0 to 3, so it will give you error because your length is only up to 2 meter. If you provide absolute 1.5, so it will apply load up to only 1.5. And if you provide 2, it will apply whole length. But if you keep relative 0 to 1, it will apply to whole length. So that is the only difference in absolute and relative. No other major difference are given.
Okay.
Sometimes we apply it by absolute or by relative. Generally, if you see in this plate modeling, sometimes require it. Or if I want to apply, that tire pressure distribution. If you remember it, then we use that.
Okay, in terms of percentage, if you want to use, we can use that.
What percentage? So relative one, otherwise absolute. If you know the length and all.
Okay.
I want to create the this thing.
Fatigue load trick.
Fatigue load. Yes. It will be required one for our this thing. Shear strut check.
So this fatigue load, when it will be used, when we have to apply and where or not, sir?
We will apply same for as a special vehicle lane. One vehicle we will try to.
For our
what will happen in
PSC composite girders, we are not applying. No, we have
no. Generally required only for steel girders. Sometimes they will ask you fatigue check. So fatigue check, nothing, just the stresses due to this repetitive cycles. So So we will go here.
That means only for steel girder we need to check that fatigue load.
Only steel. You do not require it for concrete fatigue. Because concrete does not have fatigue. Why it does not have fatigue? Concrete go permanent deformation. But steel, what will happen? Steel has reversible stress. Sometimes it come back to its original shape. Sometimes it go into plastic zone, or sometimes it remain in the elastic zone. That's why fatigue is important for steel. Concrete permanently go in permanent deformation, so no fatigue happen in our good. And we do not use plastic zone, na? We use plastic zone in steel, so that is also important. Moving load. It depends. If we are going to use elastic zone, like elastic section model, so we do not need to apply the fatigue. But shear stress generally needs to be checked because it have the reversible stress. So we just need to first of all cover user define, permit truck, mention fatigue, and we will come into our code. Now if you even
same way traffic, special vehicle also.
Same special vehicle. Life assessment of steel. Generally, we do not do the concrete or composite where transfer wheel spacing and 50% of impact factor we need to consider it. So this is also remember it. The fatigue range ranging from one single passage of fatigue load along the longitudinal direction of bridge shall be used for fatigue assessment. The fatigue load position have diverse effect, that is while outer edge of the wheel to the fatigue vehicle of the curve shall be. Okay, this is my vehicle. And this is my truck. So it has 12 ton. And 12 ton will going to be distributed in 4 tires. Fatigue limit state. Generally, we use for steel bridges. And we need to generally
telling for all we have to apply now, sir.
But generally, you have not seen for the concrete. We have not done for concrete because it does not required for that. Fatigue is not happen in the steel bridges. And if you are checking for the composite, IRC 22. And if you are checking only for the steel, if it's the orthotropic or something, so for 24. You can see bridge on rural roads not need to be designed for fatigue because that is not. Fatigue means repetitive load have been applied, and due to this stress is changing again and again, and reversible stress is occurring. So that's why fatigue is important. So let me just first of all understand how much spacing is there. This one. So I required this spacing first of all from this. It is mentioning 2, 3, 2390 minus what I will do. First of all, I will divide by 2. 1195 from this to this point I have 1195. Now if I minus 1195, 710 and plus half of 310, that will be 155. So I will get 640. So this from this to this is 640. So what here I will name it axle 1. P 12 ton was mentioned. So 12 120 divided by 4, 30 kilonewton. Spacing first wheel is 0.64. The other one is again 30. Now the spacing is
Sir, 640 is from where to where, sir?
center to this wheel. And now I need to calculate center to this wheel center. That will be 1195 minus 115. 1195 minus 155. That will be 1040. So this will be 1.04. I will click add. Now spacing will remain same. Only our load is changing. Now it is 14 ton. 14 tons. So 14 140 divided by 435. My XL2. XL2 and 3 are common, no issues. So here XL1, XL2, XL3, and here spacing we need to provide only 4.5, 1.4. 4.5, 1.4, and I will click apply. Fatigue load will be created. Moving load cases. Add this fatigue one, lane 4, eccentricity, no scale factor. Now here what it is saying, impact factor should be half. So we have considered the 20%. So it should be here 1.1. Load case name fatigue. So fatigue is also provided. Other things are provided. And now we need to see our run the analysis. See, before that we required construction stages also. No, I'm just looking at any error or anything. And now we will go into our construction stage. So here will be our construction stages. That stage 1. Duration in steel generally you will not going to be bothered by the number of days, because even if you are putting 14 days, that will be fine. But the important thing is
The fatigue position we have to apply now, sir.
position is already there. Same I have applied at the center of my bridge.
Center of the bridge, sir.
I have applied like for yes, for center of bridge I have applied. Lane 4 is at the center.
Okay.
That I have already created it. Not in time. Now before that, I need to specify the grouping. So here, first of all, my main girders. Then bracing. Then support. And boundary group also required. One will be the temporary. Temporary. I think one group is okay for the they are going to be connected. All are connected. Okay, one is fine. So, yes, so we have to go your support condition. You can see the table. Default group permanent. And then our rigid link. Then we will have some elastic links. Now elastic links after close this also. So and now for this thing, main beams. Bracing and end diaphragm.
Dummy beams is which one, sir?
I will show you. But these are the dummy beams and the secondary that in longitude transfer direction also are dummy beams. I need to update this property. Where is my property? Dummy. These are dummy also. Just 0.1 into 0.1.
Just the end portion, sir.
And portion for applying the
Crash barrier.
crash barrier. Generally for easy way, that is the old method and easiest method. Everyone do like that. So that is also shown. Save it. Now we will go into our construction stage first. So first, what is going to be activated on just duration 14 days. Stage 1. Member going to be activated main girder, bracing, and even support. And here boundary, permanent, I will add it directly. Load will be only self-fed. And then say apply. So stage 1 created. Now in stage 2, our dummy beam or secondary member will going to activate it. Apply. And delete this. But they're going to be activated at 14 days. And in boundaries, we do not require, but in load, green concrete load will be there. And apply. Then in stage 3, what going to be happen? Element dummy beam still will be there, boundary will be there, but in load, green concrete will come at this position, like it will go. And also in same stage, you can apply or no, it will not apply. Apply. Now in stage, how much stage I created? This should be 3. In stage 4, permanent deformation will be there. So element all are activated, boundaries are there, load, garage barrier, wearing code, name it stage 4. Duration will be 1000 years, days you can mention. Line and close the. So now if you look at the stage 1, stage 1, one thing is missing. Okay, bracing have been applied at this. In stage 2, this. Why in stage 3, not showing the loads. Something is not giving the quiet. Let me check it. But in stage 4, it will come. Okay. Rigid link and elastic links are showing. But loads are not showing activated. Let me update those loads. First of all, click on this, go to your base, and set, modified. Now here one more thing, increase your self-fit by 10% for connection designs or connection weights or stiffeners. These weights we can include here. Now if I go into stage
10% you are increasing, sir?
Yes. So self-weight is there.
Why, sir? 10% we are increasing.
Let me wait. Just for this, because the steel connection will increase your plates, gusset plate for connection purposes.
Okay.
Generally, they tends to increase your self-weight of your girder. These are extra one. 10-15% are the generally we take. Sometimes we take 15%. If you do not model bracings and all, then we try to put the 15%. So we have already modeled all the bracing and everything. It is not showing wet concrete. Let me check my base. incomplete. I have applied it in stage 2. In stage 2, wet concrete should come in. Okay, okay. Okay, this is support, bracing. Dummy beams are activated. Main girder. Why it is not seen when stage first? Only my girder and I do wet concrete layer. Okay, wet concrete has been gone into. No, this is crash bearing. Why it is in the default? Okay. I wet concrete could be in green concrete. I could, but I do not know why. Okay. Now, if you come into stage 2, wet concrete has been covered, but it is showing only this value. Where is my other value? Why whole something happen? I think when if I go into the base stage, no, in base stage it is fine. Now you can see this is the thing that made us do something. So if you look at here in stage 1, rigid links are also not activating on. Stage 1, stage 2. And at this point, what is it? Okay, 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 okay. The properties are even the material is fine. Why low?
Sir, this slab is not mentioned in construction stage, na sir.
No, no, I mentioned it. Wait a minute. Let me just check it. What is happening here? close window, go to your base and check tables and for dialog box, okay, up, so wet concrete. Now if you look at here, wet concrete is going around somewhere, but it should be going to create concrete and how much it is going, all are wet to here. So this needs to change on this. Now it will come. Now it is showing. So in stage 1, fine, sulfate will be there. Stage 2, wet concrete. Now it's fine. Stage 3, it will be removed. Permanent stage it will become. Now our property that has been asking how steel gutter and concrete slab will going to be separate. So now we will going to define that. One moment. And how to divide it? This point. Add. So first stage is showing lead gutter. So this will be according to your material. Material will be okay. We have not mentioned this thing. Properties need to go in base stage. Go in your properties section, material, add concrete, which will be your slab 1 IRC 40, apply, and also we will create creep shrinkage C and S, also known as creep shrinkage code our Indian IRC 1. Strength will be 40,000, 70 days, notional size 1 meter, apply. Compressive strength again M40 code IRC 112 FCT M5000 normal setting cement videograph. Okay, material link M40 and modified. So this we have created time dependent property for our slab. And now what we are going to do, we will go here and this is my 1, this is 2.
We have to apply for slab, no sir. That slab M40.
That we have already applied. Active stage 3. Age will be 14 days. Here also age 14 days. Now we click apply. Now made right hand order again. Okay. 14. 14. Just setting 1. Now, if I look in stage 1, you can see only steel gutters and the dummy. You can see even the dummy will I will shift into. Now in stage 2, my transverse member are coming, and in stage 3, it will become again composite. Then in stage 4, so in stage 1, what is there? No concrete slab is there, and we are going to check our steel gutter without concrete for lateral torsion buckling and all. So that's how you need to create construction stages for your steel composite gutter also, and also any other composite gutter. If you have even truss, if you have even bowstring gutter, if you have even a network tie dart bridge or tie dart bridge, any kind of steel and composite there. So first we need to check steel before becoming its composite. So that's how you can differentiate.
So this duration, can you show us once how it will be?
Duration, because steel will be coming from directly, manufacturer. So you do not know what is the duration, but only concrete, the stages will be there for only your slab. Other thing, you can assume it for 14 days. That steel does not have any effect due to the duration.
Okay.
Steel is permanent. Steel does not have any losses due to long term. Steel do not have creep. Steel do not have shrinkage. So this thing is only for our slab. Slab, like 14 days it will take to harden, and after 14 days it will become full, you can say full strength. That I have taken. Up to 14 days it will behave as a liquid in its liquid stage. So only your wet concrete load will be there. And what I am saying,
sir, construction stage load, can you once show that?
Wait. First group, where am I bracing? Not the bracing, dummy. So now dummy will be shit. Do not change dummy that much easily, because what will happen? These live load changes due to this dummy. Our lanes try to affect. Let me see the lanes. Yes, it is still there. There. Okay. Not changing. I will maybe create another one. Group. Crash there. And what I will do? Now what you want to see in construction stage?
First stage, the temporary support when we are using, where we are using.
I'm not using temporary right now. Direct only bearing. Because what will happen in steel, it will be temporary, but that is going to be because what is going to be happen if I use right now temporary, I cannot able to activate my bracing, because bracing is totally connected with this point, and these all points are connected to this point. So then I need to provide my temporary support at this point. So what I have done, I have provided directly the permanent one. Even permanent is okay. For steel, generally what will happen, your steel directly, because it is made up of direct steel, it is directly going to be installed on the bearing itself. You do not need to be provide any temporary for steel girders. For concrete and PCSE, generally it happens. Sometimes we change the position also. But for steel, because it is already have been casted, everything is already there. they directly put onto bearing itself. So do not need to put the
Here, since we have linked this bearing position to this
yes,
top.
yes. Everything is linked, so that's why I'm not created any.
In stage one, what only main girder and this bracing everything is. Yeah, just stage one you open, sir.
Yes, I will open. Let me just put it right. I'm base stage. In stage one, so element is opening main girder, bracing, and support.
Okay.
Because
Here,
steel will come, not direct. Yes.
in
Here,
this stage, nothing will be coming.
yes. Because here will be nothing will depend, and nothing is depend on to the time. Everything is steel. So steel does not have any time dependent property.
So in stage two, again, this
in stage two, what is happening? In stage two, I am applying the dummy being activated and applying the wet concrete load. So in stage two, we can check steel without composite action. Only steel beam we can check for concrete load, for slab load.
This dummy beam, crash barrier 2, both the things you are adding something.
Yes.
Both are same, na, sir?
Same, just same, nothing else. Because this is connected to your dummy beam. That's why I'm adding. So you can see stages like this. Now that is what I'm showing you. In stage one, only this. And if you look at the 3D, okay, in stage two, I need to remove this also. How to remove this? I need to go there. I need to go in base stage. And the main, what I need to do, just select the main girders. Yes, so now if you click on the stage one, we will have girders only. And if you look like this, nothing is there. Steel girder with bracing have been come and joined at the bearing location. So this is my stage one. Now in stage two, green concrete has come. Slab has not become hardened. So still my steel girder is there, and this is for green concrete only. Now in stage three,
load is not visible, sir. Green concrete load.
You can see here works. Here is the green concrete. Always here.
Okay.
And display it. And then when you go in stage three, green concrete will disappear and our concrete become hardened. So it has become a composite. Now in stage four, everything will come. So let me just quickly run and check, because in construction stage it will give some error. So we will see that error is any user on. Only warnings it always give in construction stage.
So after construction stage option, where you are clicking, sir? After that, you are linking again, sir, with this.
This here, composite section. Here one more important thing I have missed. I will show you. Just let it. So only warnings are here. Look the forces, the diagram, and we see the stage. You do not require submission, only that load, this. Click apply. So this is only due to your dead load of girder itself, nothing else. So you can see all bending diagrams are very equal. Even if I open the values. So 1635, 1633, 1633, 1633 something 43. So even 10 kilonewton is not that much difference. So that's how it should behave. In stage 2, if you look, it will going to increase. Why? Because now green concrete load has come. So that's why it has been increased. Now after that it will remain kind of same, because in stage 3 nothing, just green concrete have gone, but that load have been activated, concrete become composite. Then stage 4 is important. Here things will increase for crash barrier and for your other things. Then post CS, other will come like wind, temperature and all. And now the most important thing I want to discuss, first of all, select it. We will go in analysis step. First of all, see the data. Here are some calculator. We will provide reinforcement also tomorrow, and this is also if this option should be activated. If you have tapered section, so access should be adjusted for tapered section also. This consider section stiffness for stress calculation. This okay. What is okay. These two tick mark, and there is one more thing I want to this one. So here what I will try to do generally, what will happen when you do the analysis of construction stages, every load will go directly into your dead load, even if it's a crash barrier load or anything. So what we always try to do, we try to differentiate this. So here we click on this, we select dead load of wearing port and this wearing ports and utilities, and we press crash barrier. Here also CB, or if you name it crash barrier also. So it will not going to be added in my dead load. Okay, now again wearing ports.
So why we are doing this one, sir? For bifurcating?
I will tell you. Wearing port. Okay. What will happen when we try to run? Let me run it. You go into the result tab, and if you go into the sources beam diagram, and if you look at the stage 4, in stage 4 we have applied dead load, wearing ports and crash barrier. Now here crash barrier and wearing ports coming separately. Before that did automatically comes with the dead load. That's what I have done. Now if you look
We
at
want
here,
to bifurcate for dead load and crash barrier wearing cost separately.
yes, now you can see crash barrier wearing port everywhere. But I think it will not give anything because it had not been applied at this situation. It has been applied in 4th stage. So if you look at here, it will give something. And where is this? You can see this is giving. This is giving. Then we have dead load also. So now that what I have done. Okay. Now we need to create only the load combination and design it. So we will do it tomorrow, I think. So
Sir, load
yes.
if you go to load construction stage, where it is, sir? Load if you click the top.
Load, here is the construction stages.
Right.
Here if you click CS, these are the one. And if you click composite section for CS, it will differentiate your composite section.
This one is what, sir? in this composite section for CS?
That we have done here now by differentiating steel girder and our slab, this thing.
Okay. This one we have done.
Uh,
This H value, no, we are updating anything as error. It is
it
automatic.
will automatically update. It is coming by automatic. We do not need to do anything here.
Okay.
It will automatically. So update all H if you want to consider, even then again it will update. Recalculation and recomposite H can stay successfully. Then update long term. Just click, then again run. No issues with it. If you want to do, you can do it. So now our main part has been completed. We will go for the design part. Before design, combination.
So this bracing and other things and all we have not bifurcated.
We are going to design it. I will tell you in the design we will differentiate these all.
No, not that, sir. Here in this composite section for CS, only the main girders we have differentiated.
Bracing or the steel, na? There is nothing. It's a composite one. There we are only differentiating the composite sections. Bracing or steel. Why should we differentiate anything?
No.
Whatever.
Mid girder, right hand girder, left hand girder we have selected and we have differentiated, no, sir. In composite section.
So bracing does not have any differentiation. Bracing is fine. But you required any differentiation in bracing? I'm not getting your point.
Okay.
Can you little bit because bracing is in whatever direction it will go, it will remain bracing. It will not behave right bracing, left bracing, or top or bottom.
Sir. Means in composite section for CS, we are selecting the numbers, no, sir. You click that, sir.
This one, no? So we have selected only girder. Bracing does not have any concrete thing. So here, if you see, we need to see the section which have the composite. So only three are the composite: main girder, right, and left. And diaphragm only have one. It will not show nothing.
Only
Same
this
for bracing.
we have to separate from deck slab.
Only for composite section.
Composite section. Okay.
Nothing else. Okay.
Okay, sir.
So tomorrow we will do design. Everything is completed to this point. So let's go. Okay. Bye. Bye all.